Hello and welcome. In this lesson, we'll go over some more graphs of rational functions. I put together a variety of rational functions for you to practice. The first example is linear over linear, and then a linear over a quadratic, and next a quadratic over a cubic function. So the first two examples are examples that we have discussed in class, but I'm going to go over them briefly. We're finding the x-intercepts first by making y equal to 0, which means that 0 equals 5x minus 10, and that tells us that x equals 2. So the x-intercept is at 2. For the y-intercept, we evaluate the function at 0. So y equals 0 minus 10 over 0 plus 3. Remember, we have said that the y-intercept is the ratio of the constant terms. So negative 10 over 3. Next, the vertical asymptotes. 2x plus 3 different than 0, which means x different than negative 3 over 2. That tells us that the vertical asymptote is at x equals negative 3 over 2. Horizontal asymptote, we have linear over linear, so same degree, which means that we compare the coefficients of x, the highest degree term, and we'll say that the horizontal asymptote would be y equals 5 over 2. So for the behaviors, it means that we are going to try to find what happens to the y values as x approaches infinity and as x approaches negative infinity. So let's get started with the graph. I'm going to draw the axis, and I will try to scale it as precisely as I can. So here we go, 1, 2, 3, 4, 5. And you get the idea. So we are going to draw the asymptotes first. I really like to label the axis. Important. So we have an x-intercept at 2. We have a y-intercept at negative 3 point something. You have to find the decimal value of it using a calculator, but on the chart usually you want to show the exact values. And we have the vertical asymptote at negative 3 over 2, which means right at negative 1.5 here. I will label the vertical asymptote by its equation. We have a horizontal asymptote at 5 over 2, which is 2.5. And again, I will label the horizontal asymptote as well by its equation. Let me bring it right at 2.5. So this would be 1, 2, 3, just to get an idea where we're going here. And now we're thinking, where is the graph located? So remember that the vertical asymptote will divide the domain of the function. So whenever we discuss the location of the pieces of the graphs of rational functions, we always look into the domain. So for the values to the right of the asymptote, where would the graph be? Apparently here you see that we have 2 points on the right side, which means that this will be our guiding points to graphing this function. And we'll say that the graph will follow the asymptote and pass through the intercepts. For the next piece, we are going to take a look at the x values to the left side of the vertical asymptote. We'll pick a value, negative 3 for example. If x equals negative 3, the value of y would be 5 times negative 3, negative 15 minus 10 over negative 6 minus plus 3 here. So that's negative 25 over negative 3, or positive 25 over 3. That would be about 8. So let's find out where 8 is. So 3, 4, 5, 6, 7, 8. So at negative 3, the graph will pass at this point. If you would like to add more accuracy to the graph of the function, what you want to do is pick another point, and I would pick a point further left because it seems that the graph will approach in this direction. So for this, for now, what I'm going to do is draw a shape symmetrical to what I had in this section of the graph, and voila, this is a graph. So for the end behavior now, we're going to say that as x approaches infinity, the y values are below 5 over 2. As x approaches negative infinity, the y values are above the asymptote, so above 5 over 2. Now, we can also analyze what happens when x approaches the vertical asymptote, which is at negative 3 over 2 from the left and the right-hand side. So when you approach negative 3 over 2, which is right here, from the left-hand side, the graph is going up to infinity. So we'll say y approaches infinity. When the graph approaches negative 3 over 2 from the right-hand side, the graph is heading towards negative infinity. So we'll say y approaches negative infinity. And here we go, we're done. Moving on to another familiar example, we have f of x equals 2x plus 1 over x squared minus 4x minus 5. We have a linear over linear. So we'll start with the x-intercepts by making y equal to 0, which means that the numerator must be 0. That tells us that the x-intercept is at negative half. For the y-intercept, make x equal to 0, which means that the y value will be the ratio of the constant terms. So that would be the y-intercept, negative 1 over 5 in our case. Vertical asymptotes, we're going to need to find the restrictions for it, which means that we need the function in factored form, or at least the denominator. So the factored form of this denominator is x minus 5, x plus 1. That tells us that this function will have two vertical asymptotes, one at x equals 5 and one at x equals negative 1. Next is the horizontal asymptote. We have a linear over a quadratic, so practically it's y equals 0. If we want to explain the reason one more time, we look at the highest degree term in the function. So we have power 1 and power 2 and power 1. So that means the highest degree term is power 2. So that means f of x equals 0x squared plus 2x plus 1 over x squared minus 4x minus 5. So there go the ratios. There goes the ratio of the leading coefficients. And we'll say that the horizontal asymptote is at y equals 0. Now for the end behaviors, we are going to discuss the values of y as x approaches positive and negative infinity. So here we go again. We're going to plot the points first and the asymptotes. So notice that the vertical asymptote is towards the positive, so I'm going to draw my vertical axis a little bit to the left to have more view in the positive x values. I'm going to scale to the best of my ability here. This is 5. And here goes the x, and here is the y-axis. Here we go, 1, 2, 3, 4, 5. 1, 2, 3, 4, bam, bam, here. Now, x-intercept is at negative half. Here is negative half. Y-intercept is negative 1/5, so approximately here. The vertical asymptote is 1 at x equals 5. Let's draw one here. And the other asymptote is at negative 1. So here goes the vertical asymptote at negative 1. The horizontal asymptote is at y equals 0. So right here. So let's label them all. Vertical asymptote, x equals negative 1 and x equals 5. And horizontal asymptote at y equals 0. As you see here, we have the case where the function will cross the horizontal asymptote in between the two vertical asymptotes. So let's take a look at what the shape of the graph is going to be like. Remember that we always discuss the shape of the graph or the presence of the graph in the three intervals or in the intervals that make the domain of the function. So the two vertical asymptotes divide the domain of the function into three intervals: bigger than 5, between -1 and 5, and less than -1. So for bigger than 5, if you want to know where the graph will be, either above or below the horizontal asymptote, we pick a testing value, or we pick a value of x, in this case, x equals 6, and we evaluate the function. So 2 times 6 plus 1 over 6 squared minus 4 times 6 plus minus 5. So this will be 13, and this would be 6 squared 36 minus 24 minus 5. So 36 minus 29, that's going to be a 7. And 13 over 7 will be about 2 units, which tells us that the graph will be in this section above the horizontal asymptote. So we are going to make this point visible and draw a curve that approaches or follows the asymptotes. Now, next I'm going to actually deal with this interval. So to the left of the x equals -1 asymptote. And for this, I will pick a value of x equal to -2. So the value of y will be 2 times -2 plus 1 over -2 squared minus 4 times -2 minus 5. So we have -3 over 4 plus 8, 12. 12 minus 5 equals 7. And this will be a negative number, -3 over 7. So at -2, we have -3 over 7, which is going to be even less than a half. And that tells us that for x values to the left of -1, the function or the graph of the function will be below the horizontal asymptote. So here we go. And now let's take a look at what is happening in between the two vertical asymptotes. Whenever a function has or whenever the graph of a function intersects the horizontal asymptote, I check for two values in between the two vertical asymptotes. One is to the right of the left asymptote, and one is to the left of the right asymptote. It's like a play of words here. So I'm going to check with left of 5. So I will give the function, or I will pick an x value equal to 4. So the y value will be 2 times 4 plus 1 over 4 squared minus 4 times 4 minus 5. So this would be 9 over 16 minus 16 over -5. So that tells me that the function at x equals +4 will have a value of -9 over 5, which is about 2, but less than 2. So now I know where the graph will be located, and it has to follow the asymptotes. This time I don't have to check close to the other vertical asymptote because I already have points close enough to it. So I will draw the curve in such a way that the graph is approaching the vertical asymptotes, and this is the graph.